Hi everyone, welcome back to Azure 0 to 0 series. In last video we discussed planned and unplanned maintenance. We also discussed about unexpected downtime which can happen in Azure data center. So how you can make sure your application is available when there is some planned or unplanned downtime. So there are high availability solutions offered by Azure along with some load balancing solutions. So in this video we will discuss load balancer, Azure load balancer, and then we will go with the high availability offering by Azure. So again, let's start this discussion with our old example where you are a startup company and you have one website hosted in Azure virtual machine. There is one public IP address for your website, and all users are reaching to this particular website on that public IP address. So this environment looks good if your business just started or it just dev or test environment. However, for production environment, it comes with some challenges. Challenges like single point of failure. It means if this particular machine goes down for whatever reason, it could be data center outage, it could be the underlying host failure, or it could be something else, then your website will not be available. And that's where single virtual machine has SLA of 99.9. So how you can tackle this problem, and that's where Azure Load Balancer comes in picture. Azure Load Balancer is nothing but a solution which will distribute your traffic or web traffic in multiple backend resources or server. There are two types of load balancer, which is public and internal load balancer. We will discuss these two load balancers in detail. Then load balancer works on 5-tuple hash. It means it will compute the hash of source IP, source port, destination IP, destination port, and the protocol what you are using. Is it like TCP, UDP, or so on? So accordingly, it will map the traffic to available backend node. Load balancer uses health probe to determine health of backend node. I will discuss more on health probe in upcoming slide. So how load balancer work? Let's see this with a simple example. Same old scenario where web traffic is reaching to your public IP address. Then you add load balancer, or you add the public IP in the front end endpoint of load balancer. And then you have maybe two machines configured in this load balancer running the same workloads or hosting the same web front end site. Now as traffic is coming, load balancer is distributing that traffic in among these two servers. As your business grows, you add one more server and so on. So this is how with this example there is a load balancer which is distributing this web traffic among these 5 web front-end servers or 5 web servers. So what if this particular node goes down? Then load balancer will detect that this node is unhealthy for whatever reason, and it will not route any traffic to this particular web01 server. If any traffic is get routed here, then those users will get website unavailable error. So that's where load balancer will remove this web01 from traffic distribution, and all the incoming traffic will get routed to web02, 03, 04 and 05 servers only, so that none of the user will get that unresponsive website page. And this is how load balancer distributes the traffic. Now as I said, I just want to discuss how load balancers will detect if this web01 is healthy or not. So that's where something like health probe comes in picture. Health probe is nothing but some rule where you will ask load balancer to check if this web01 is alive on port 443. It will keep probing the web01 for port 443 it will keep checking if 443 is responding or not, and if that port is unresponsive, if load balancer doesn't get any reply from web01 on port 443, it will just remove that web01 from the load balancing solution. And you can define the time interval for how long you should check this server, after how long you should remove this server from the load balancing, and that's how you configure your health probe rule. So simple example of health probe will be, check if this server is responding on 443 for 5 seconds. Check this similar thing for 2 times. If there is a no response, then remove it from load balancing solution. Then we have different types of load balancing rule. The one which we already discussed, like suppose HTTP traffic is coming on port 80, and then it will get distributed among the backend servers what load balancer has. Apart from that, there is something like inbound NAT rule. You will come across this NAT terminology very frequently in Azure when you are dealing with Azure networking concepts. So what is NAT? It's network address translation. I'll explain NAT with a very simple example. When you call some call center or service center, example Vodafone or Airtel, you just have one number, then you call them, they will there will be what automated voice system which will ask you for billing press 1, for some service request press 2, for network related issue press 3, something like that. Then depending on your input, your call will get routed to respective department. So similar way, load balancer is a single point of contact for all the users. They will reach to load balancers and load balancer front end IP address, and if they are reaching on 3389, then load balancer will smartly transfer that request to a server which is hosting or which is configured to accept RDP connection. Same way, load balancer will see this is like requesting on 443, someone is reaching on 443, it will route that traffic to this particular server, and similarly for HTTP. So that's where, if you remember, we talk about 5-tuple hash. What is the source IP, destination IP, source port, destination port, and the protocol. So this is how load balancer will use this terminologies or this technology for routing the traffic. Moving further, we have 2 types of load balancer. One is public load balancer and other is internal load balancer. Now, what is the difference between these two? The only difference is from where traffic is coming. So for a public load balancer, it will be the public facing or internet facing load balancer, where users will reach to this traffic from the internet, and then traffic will get distributed to our web server. So you can imagine the earlier scenario where traffic was getting distributed across 5 web front-end servers. Similarly, internet traffic is coming to load balancer, and load balancer is distributing that traffic to this 3 web tier. Now after this all 3 servers will send the traffic to load balancer, and again the same traffic will get distributed to some business tier virtual machines or example database virtual machines. So if load balancer is receiving traffic from the same network or inside the Azure, and it's distributing to some other backend servers, then it's internal load balancer. So quite easy to understand. If traffic is coming from internet, it's public load balancer. If traffic is originated inside Azure network, then it's internal load balancer. And as I said, it's just a fundamental series. We just discussed the concept of load balancing or Azure load balancer, but definitely as we move further, I will create videos on practical how you can create load balancer, how you will map backend pool, how you create load balancer rules and health probe rules. So please stay tuned. Please like, follow and subscribe, and you can post your questions in comment sections. Thanks for watching.